Welcome back, everybody. Thanks for showing back up. It's been a long road. It's just like, wow. And this is like the last thing I think. I'm not sure, but I'm pretty, how can I put this, confident that this is the last thing before I put on the lift to do the suspension skid plates, exhaust, onto the rotisserie. But how can I put this? This is going to be kind of not haphazard in such a small area, but it has to go back and forth. There's a lot to get done. And what it is we've got pretty much most, the front end pretty much done, the rear, the center, the front 8-pillar hoops pretty much, along with the gauges and dashboard and all that. But what we have to do is the firewall. And I keep looking at it, and this is one thing you're going to run into. You're going to build a car and you think, oh, I really thought it out. And I thought I did, but it's like the air cleaner. I really thought that out, but I'm gonna have to redo it. Because when I get everything in here, like I went from here to there, from there to here, and this is where our meeting is in the middle. And in the middle is showing some shortcomings that I did. It's not bad because I didn't weld in the box or anything. I just have to shorten it. And we're gonna change the position where the ECU is gonna be to actually make it look more like the original. And I'll show you a picture here in a bit when we get to that side. First thing is, we have to sit there and do the firewall for the brakes. That is our big thing. And I want to do a dual master cylinder setup like the original cars have. That's what I want. And I just really like using dual master cylinder brakes. I built a whole setup for my original Audi Quattro. I have in my Escort that I rallied, I had dual master cylinder pedal box. And in my street Escort, I built a dual master cylinder pedal box, but that thing is completely removable. Actually, it's pretty cool. But looks really hillbilly, but it works. Other than that, I'm sitting here drinking my coffee, looking and going, all right, what's the first thing because it's kind of haphazard, what's the first thing we need to do? And I think it's the biggest component on it, and it's the brakes. That's what we got to do first. So let me come over here. I'm going to show you what space we have here. I'll bring you over. I'm going to show you right over here another car. And then I'm going to go over and look at what we're going to do on the bench. And that's going to be, it's interesting. At least I think it is. And I'm going to try and build it. And there's a certain way I want to build it. Whether or not it works, we will find out. Because it's, how can I put this? The main thing is getting the firewall done. And that's making this plate for the dual master cylinders. And modifying the original pedal assembly to accept it, balance bar, all that stuff. So, all right. Without any further ado, sorry for that long-winded introduction, but it's yeah. Let's here. Let me show you what's here. Then we'll flop around and get to the bench. The firewall. We're going to do this in pieces. So let's just concentrate on the braking and clutch hydraulics. That's what we're doing. Right here is where the original is. This is where the extension plate, then it goes into the vacuum canister. We're going to be getting rid of that. Right here, right down there, is where the clutch master cylinder is. I want to go as far in as I can to have the dual master cylinders right there so I can easily service them. You have to remember, this car is also going to have this right here. So we need to have I want to have the master cylinders like right here and the clutch master cylinder right here so you can easily service it. Even though if you have to stick your hand down through, you have to stick your hand down through, but I think it's going to work. But I want this all flat and I want to make sure this is, how can I put it, very, very strong. That's my big thing. Let me show, I have a car, let me show you on this 4000 I have right here, what sometimes happens with the clutch master cylinders. Here is the clutch master cylinder. There is a firewall that's basically split. What it was, on the clutch master cylinder here, the reinforcement plate goes all the way around until it bends. This bend down here is reinforced. This bend where it goes, which basically makes the inset for the clutch master cylinder, is not reinforced. That is the problem with having bends next to a movable part, because what happened was it created weak points. Or if I assume there's probably rust in there or cracked or something, but when you have a 4000 Quattro, take a look where if your clutch pedal feels kind of mushy, I would look there. Just for preventive, just to be preventive maintenance, you know. Then, or if you're buying a car, just look and make sure it's okay. All right. So let's go over to the bench and start working on the pedal assembly, and so we can get rid of all of this on the rally car. I brought the bench over here in front of the rally car. One thing I have to start explaining is the reason why we're doing the dual master cylinder setup. All right. Let's first go into how can I put this? The different types of brakes that you have for a general Audi, basically. This right here is not an Audi. I think it's a Subaru, but same thing. It's a single piston caliper that slides on a mount right here. This would be the upgrade, which is called the G60. The G60 has two pistons. Same thing, slides on the mount. This is a rear, has a single piston, slides on the mount, and you can tell it's a rear because it has e-brake. Now, if you go into like older cars, right here is same thing. This is from a Saab. It has two pistons either side, and basically they clamp together with mounting right to the actual strut assembly. Now this right here is a racing brake. This is an AP caliper, and it's called a radial mount caliper. What it is let me take this off. This right here is a radial mount. This bolts to the strut just like this mount does, but it doesn't have the caliper bolts onto these two bottom pieces and bolts like this. What does that do? Well, what you can do is have this mount on there. Let's just say you're going from tarmac or gravel to tarmac. Gravel, you use 15-inch rally tires or 15-inch diameter rims, and tarmac 17, 18-inch rims generally. And what that does is that if you don't have, I mean, your braking system's all set up to do a certain amount of volume or amount of swept area to push the pistons through. What this does is you can just add like a riser or a dummy plate or whatever, and bolt this caliper to it and increase the rotor size, which gives you a little bit more swept area and a little bit more dissipation because of the area of the rotor that you have. Now, let's get into the master cylinder. So this right here, Audi 4000 Quattro master cylinder. What it is we have a single master cylinder. I believe it's a 19 millimeters, 3/4 inch bore. Can't really remember. I think that's what I think the rebuild kit was. And right here you have a proportioning valve. What happens is, when you push that plunger down, it puts a certain amount of pressure, unregulated, to the front calipers, like to this caliper. Because what it is that you have a piston. Let's just say it's 30 millimeters across. They're a lot bigger than that, but let's say 30 millimeters across on the fronts. And what happens is when you push that thing, that entire amount of fluid goes to that 30 millimeter swept area of the piston, and that pushes the piston on to, pushes the brake pad onto the rotor. Usually on the back, what happens is the pistons is usually about 3/4 of the size, because you don't need that much braking pressure on the back. Too much braking pressure on the back, it'll be like the old Maserati bi-turbo. Slam on the brakes, the rears lock up. That's just what happens. That's what this is for. This right here is a proportioning valve. It reduces the amount of pressure and volume, basically, going back to the rear calipers. That creates less of a, how can I put it, less of a clamping force on the rear calipers, so it distributes the amount of force to the front and to the rear. All right, now what are we doing? Well, we're using a dual master cylinder setup. What does that do for us? Well, let's say we have one master cylinder here. Let's say this is 19 millimeters. Let's say we have another master cylinder. Let's say this is 16 millimeters. What happens is the amount of volume pushed through this 16 millimeter master cylinder is going to be a lot less than the 19 millimeter master cylinder. So we don't need a proportioning valve. If we get this wrong, which a lot of times I do, because I'm just guessing at it, we use this. This is a, it's called a balance bar. And what it is, it exerts force on a master cylinder, a greater force on one side, you know, because what it does is it slides back and forth. You can adjust it like this. It keeps it there, and let's just say it's like this, rest, and when you push it in, it's like that, but it travels so much further, it pushed that much more fluid out to compensate for the mismatch in brake master cylinder to the rear. All right, so what are we going to do here with all those parts? Well, we're going to make a braking system with that down there, and I'm going to show you the reason why here. All right, let's go there. All right, here's the pedal assembly we're going to use. Coupe GT pedal assembly, 4000. I think it's Coupe GT because it's rusty, and both Coupe GTs I have were rusty. What it is that what's the aluminum section, the same as the 4000 Quattro. The steering assembly right here, same as the 4000 Quattro. What's different? The pedals are different. The pedal on the Coupe GT, it's a cable clutch, does not have the provision for the pin for the master cylinder. On the brake system, same from like here up, but the pedal needs to be moved further over along, like the clutch pedal needs to be moved further over to accommodate the wider transmission tunnel in the 4000 Quattro. Because the transmission tunnel was wider. We've already seen that. Okay, now, also, I gotta modify the clutch pedal to accept a hydraulic clutch master cylinder. What it is seeing how I have to go through all that, guess what? I am gonna use this. Remember this? This was the clutch master that I put in the Sport Quattro. It's a B3 Passat. Much better availability than the 4000 Quattro. 4000 Quattro stuff is kind of drying up and it's getting expensive. This stuff you can still find pretty cheap, and they made an awful lot more Passats than they did 4000 Quattros. So you got to think of it that way. And they also put them in the Corrados and stuff like that. So this is the reason why I want to use this, because that way if I have one master cylinder and let's say I convert my Quattro upstairs to this, and I have another one, you know, that I converted to it. Guess what? If I have 4 cars that use the same master cylinder, if I see something on closeout, $20 a master cylinder, I'm going to buy like 5 or 10 of them. That way I always have it, lifetime supply, no problem. I mean, very rarely do they fail, you know, but when they do, guess what? I would have one. And that just gets me on the road. Worst comes to worst, let me see, where is it? Right here. This is an AP master cylinder. What this is for a hydraulic handbrake. But take a look. There is a rose joint on the end. If you look at the length of the rose joint and this master cylinder, on this clutch master cylinder, same. If I get into a real bind, I can re-drill the holes, put one of these in there with a Heim joint, and get on the road. You know, that's the thing is, it's just like, it gives you an opportunity to expand out a little bit easier. You know, with a standard rod, you don't have to recut a rod or anything like that. So that way, what I want to do is I want to put all of these things, and I want to go out and get some material. I'm going to bring it in. I'll show you what I'm going to use. But the whole thing is we need to make this assembly, convert it from a cable to a hydraulic master or hydraulic, actuation assembly, and we have to move this pedal and put a balance bar in here and make it work without hitting the the steering shaft. Yep, I know it's a long time. It's going to be a lot. It's going to be a lot. So, all right, let me run outside. Let me grab the stuff. Let me come back in and show you what I'm going to use for more hillbilly materials. You're probably saying, all right, what the hell is that? This right here is a front bumper support from a Merkur XR4 Ti American. You know, it's an American 5-mile-an-hour bumper. Pretty much, I mean, the car was in a fire heavily over here, not over here. It was just charred over here, but everything's straight. It's fine. It's not perforated. The base from the drafting table. So I got to use more of this, because the gauge, you know, what's this is all 14 gauge, super thick metal. Then we have to build the pivot arm assembly onto the brake pedal. We have either this. This is one of the mounts that I cut off of the crossbar, you know, from a Subaru that I cut off of the crossbar for the dashboard. Or I went digging and found more Eurovan seat parts. I'm hoping to use this, but that might be a better fit. We will see. First things first, let me cut some chunks of metal out of this and out of that, and then we can actually figure out what we're going to do and how we're going to build it. Because I still don't know. I'm still winging it and figuring out until I can get the raw materials put next there, and actually the raw materials cut and seeing exactly where the master cylinder is going to go, or the master cylinders are going to go, and the clutch master cylinder and how I'm going to do it. Then I can figure out which way everything's going to basically go into the firewall. All right, let me get my stuff on so I can cut this stuff up. All right, we're here at the firewall. What do we have? Well, I took my thickness gauge, and what it is the firewall is 18 gauge steel. Down here is the only reinforcement plate there is on the firewall in this section, which is the clutch master cylinder. And as you saw with the 4000, under high stress, it breaks right here. So that's the kind of the reason why I made this thing so large, because I'm wanting to use a 14 gauge plate to disperse the energy all the way across. And if I can weld it, take out all of these holes, you know, fish this line back through, but take out all of these holes and weld it directly to the tower, and then directly to here, because I'm not going to go past here. Right here is the accelerator cable, and I really want the fuel lines to come out there. So that's kind of what I'm really heading towards. That way, this is all one section. I can get rid of it all. I can weld it into the top here, weld it into the base there, and then make everything all set for, as in, how can I put this? Ease of, it just like, it eliminates a lot of holes. And if you can close up all the holes and weld it all sealed and just have your cylinders right there, that way, if I want to have wiring coming out, I know I can put the wiring harness like right over there or right here. I just have to drill a hole. That's it. So that's pretty much easy enough. But first things first, I got to make a template for this onto that. And let's go over to the computer and let me show you what I have for information to start out. That's the big thing. And it's going to be a multiple templates up and down because it's going to be layered all the way in. So yeah, another one. What do I get myself into? All right, let's just do it. Here we are at the computer. What it is, I got a diagram or assembly instructions from Tilton themselves. This is for their 600 series, basically firewall mount, master cylinder, brake pedal, clutch master cylinder, all assembly. Actually, it's a very nice assembly. Now, what I'm looking at is the dimensions to the right of that. What I need to do is when I do my template, the template has to have the holes for both brake master cylinders and the clutch master cylinder. Now, the first thing is you can take a look at center hole to center hole is going to be 66.5 millimeters for the two brake master cylinders. So that's a good indication. Okay, you know, one hole right here, then we'll have a hole saw and go through. But that's later. And then if you take a look at their assembly, their clutch master cylinder is all on the same line, and it's exactly equidistant from the last brake master cylinder to the clutch master cylinder is exactly 66.5 millimeters. That's what they did on their assembly, and they know a lot more than me. So I'm going to keep mine all on a straight line. And what it is that we can't have that distance with the clutch master cylinder and brake master cylinder because we're using a different pedal assembly. This is the pedal assembly that I showed you we're going to use. This is the Audi. Now, if we're looking at brake pedal and clutch pedal, on the diagram right here, in between center to center for the brake pedal to the clutch pedal is exactly 100.1 millimeters. Well, we're not going to have that because if you take a gander at this, when I measure it out, it's about 133 roughly, 133 millimeters in between the brake pedal and the clutch pedal to keep everything in straight line, you know, for the actuator rods. So we're going to have to add 33 millimeters, so let's say 33 and a half millimeters to make it even. So for our hole to go from the clutch, the farthest over brake master cylinder to the clutch master cylinder will be 100 millimeters. So let me get some cardboard, a pen, and a compass, and let's start making this, making the template so we can start putting in there and figuring out where exactly this assembly is going to end up. The first thing I want to do is, we have the whole brake assembly right here. This right here is the balance bar adjuster. We have to have this little tube welded onto this. What I have here is the most we can run over is see where this clip is, this pin, and where the clip is, and there's a bushing. Well, that's as far as I want to go, because that shows me, okay, I can go all the way down here. What that is almost virtually the same width of this, so I can actually have it a little bit thinner, run it in. But the one problem we are running into, if I put it like in the actual assembly, is it's going to hit the steering shaft. That's the big thing. It's not a straight shaft. It has a rubber guibo, if you want to call it. That's what we used to call it on the Alfa Romeos, you know, for the drive shaft guibos. That's, you know, they're basically a huge one. But what it is, we want to put this here, and we want to make sure, depending on where we have it, we don't have too much deflection. That's a big thing. So what do I mean by that? What I mean by that is, here's the master cylinder, and it only has so much deflection. Any more, it's creating stress on the actual cylinders, you know? So you can go down like this, you can go down like that, but I want to have it like at rest down here, at full pressure in the middle, and at the very end maybe go up a little bit, but I'm trying to eliminate a lot of it. So how am I going to figure that out? I put a parallel plate on here, and it's just a piece of steel. That's all it is, just a flat edge. And what I did is, the inside here is not really flat. This is flat because they want it to mate up against the firewall. So I put this right here, and I look at it going, all right, here is my pin for where the rod for the brake booster goes, or for the brake master cylinder goes. I look at it going, all right, well, how much in that arc do I have a deflection? Well, I have probably 3 or 4 millimeters of deflection in it, looking at it straight down on what it is. So we're going to try and replicate that, but I want to replicate that further towards the firewall is what I want to do. And I need to get, here is the representation where that is. I need to have it like right around here, you know? And we're going to have to cut all this stuff off, but we're going to have to brace it in another portion. But you have to remember, I'm not using the 18 gauge of the firewall in order to brace the entire thing. I'm using a little aluminum, probably about half as thick as this, but I'm using twice as thick as steel. So what it's going to do is, it's going to actually, how can I put this? The steel will actually be a much more of a support than the actual aluminum will be a support, because this is actually lighter than what I'm doing. You know, of course, you know, I'm not an engineer, but this is kind of what I'm just looking at for right now. Our main problem is making sure when this thing goes up, it's not going to deflect up and down too much. Now let's take a look at what the material I have to use this, and I'm probably going to use the Subaru portion. Not too bad I can't use the Eurovan seat portion, but we're going to set this up and see about how we're going to make this work. Okay, I have 3 3/16 basically from this edge to the firewall section of the master cylinder. What I'm trying to do here is as you can see, I got this much free play where nothing is constricted. So what do I have for free play? If I do this right here, not on the, it's about a ½ an inch on the ruler because I didn't, it's not close to the metric measurement. Doesn't really matter. We have to set it up like this. So what are we going to do? Well, we need to understand where these are at first. Now, if you look right here, here is where the original firewall is. Right there. So we would have to extend something, that bracket that I have, out to here to make it work. Now, if I cut this plate where the straight edge is on, and I bring it back, it gives me a lot shallower, shallower support from here to actually go against there. So one thing I have to consider next is where the clutch pedal is going to go. Here's the clutch master cylinder. And if you sit here and look at it going, all right, well, if I do another type of, extension from this, if I make them all one point, because this master cylinder on the car is about 3/4 of an inch inset into the cabin, if you want to call it, because it's an indentation. What it is that, okay, I want to get everything set up on one plate. Now, if we're going to be building something for this, it's actually going to look just like that. I need to do the same thing, but I got so much more leeway right here, I don't want it to go too far like this because it'll bind up. But when this thing goes like that, when you depress it, this bolt will move in pretty much, so it should. But the way I want it is I want this thing maybe just a little, then it'll go like just a little bit like this, go like that, then go like this. So there's no binding of the rod on the actual clutch master. At least that's what my plan is. Let me sit there and look about where I should cut. And actually, let me get that piece from the Subaru, and because it's so much thinner than the Eurovan one, let's start cutting that thing up and mocking it up and seeing roughly how we can do the master cylinders, because I want it welded onto here and also welded onto this point out here, so it makes a box section. So it's going to be really strong. I got to pull it off and pull the spring out, pull this out, pull the rubber bushing out, and that's when I'm going to weld it on there. But first things first, let me get that piece, and then we can start cutting that up and figuring out, all right, let's see where it needs to go, where we can get the most amount of coverage. Here's the assembly. What I did, just drilled a couple holes, hogged it out, made sure it's equal. That's kind of the whole deal with the sleeve, is I'm just going to hog it out with a die grinder to a point where it's just going to, right underneath it, then I'll just file the fit so it's nice and equal. Main thing is, I'm sitting there trying to figure out where on this I'm going to put it. I think I'm going to have to start trimming this piece because it's all going to be file to fit. And this piece will be done at the last portion of it, because I'm going to weld, when I weld the sleeve in, it should be all right. But we also have to get it further enough over here where, I mean, it's going to be close. It is going to be really close, as in section on this right here. I think we can do it, but let's first, I'm going to continue, shaving this thing down, making it form fit to the pedal, possibly tacking it in. I'm not really sure yet. But it's, yeah, it's one of those things where if I do it that way, it doesn't work. Yeah, I'm going to have to do it this way because it fits over the pedal. But let me start cutting this more and trying to figure out exactly where it's going to go, All right, I had to reposition it off camera. And I mean reposition it as in like 4 millimeters down. Because I wanted to get it exactly in line with the original clevis pinhole for the brake booster. The big thing is I'm running into is this right here for the steering shaft, this guibo. I have to take it out and sleeve it is what I'm going to have to do. The reason is okay, off camera I moved it out. I tried to get it right here where it would be okay and nothing worked. So guess what? If we can't have this, this thing interferes with every direction we have, you know what? It's going to just get taken out. Next thing is I got to pull off this spring, pull this off, pull the nylon bushings out so they don't melt, and I'm going to weld this up a little bit better and trim it around a little bit. But that's pretty much, I mean, where it sits, it's actually pretty decent. I'm looking at it, it's absolutely square on this way. That way when I put a plate in right here, it's not going anywhere because I'll weld it all the way around, weld the plates in, weld this back, that's fine. Now, the big thing is, let's get on to doing the clutch pedal. That way I can start figuring out where to cut the center steering column. Balance bar assembly pretty much in. Yes, I have to trim up all this and box the sections back into the pedal, no problem, but we have the position. Next thing is we have to figure out where these master cylinders are going to sit on the firewall. If you sit there and just put this right in the center, right there, we're going to have to take this big section out right here, and we're going to have to notch out this section right here to allow this union, if you want to call it that, or clevis, to go down inside and have it go back and forth without any obstruction. So let me get out my stuff and let's cut it out. Well, I have it pretty much cut up to where I can put the aluminum plate in and lock it in. And that way we can figure out exactly where we want the setup for the clutch pedal. I'm not going to be able to use the clutch return spring. All I'm going to use is a spring just like on the brake pedal. That's all they had, and that's what I'm going to have. It's going to be right here. It's not going to be hard. So I'll cut this little doohickey off. But first things first, let me get the aluminum plate. Let's figure out exactly where I can cut it, or drill the holes to allow the master cylinders to set in, and then we will make the place or position for the clutch master cylinder. What I'm going to do is I'm going to bring in a centimeter in from the side. It's 42 millimeters across. This is 21 right here. So this should be my first one. And 66 and a half. master cylinders are on the plate. What I didn't want to forget to tell you, when I set this up, I always set it up so the maximum amount of thread is in the is in this pin. So what I do is put that right there. That's the maximum amount. We can go further in, we can go further out, but this is the most amount of thread right here that's going to be in contact with this. So it should give us the most amount of, how can I put this, most amount of strength. So that's kind of, you know, we can go further in, we can go further out, kind of don't want to, but I want to get everything pretty much set up just like this. Let's do a little bit more trimming, but not so much of a problem. Here's the assembly. I trimmed it all off right here. I got to clean it all up. I got to tack it. What it is this thing, it moves back and forth. I lock the brake pedal as close, you know, where it's going to be in initial form. Now we have this cleared off, so this thing will, this piston will go all the way down to here with no obstruction. What it is it's very, very close. It's a little off, but this thing is not centered. These things have to be centered correctly. This one's a little cocked this way, and that way it needs to be brought in a little bit. So, what am I doing now? What am I doing now is I got to figure out where exactly the clutch master cylinder is going to go. I think it's going to go right here, but let's see what we have for mounts that I'm going to use to mount the pin that'll hold it. So it's, yeah, I think it's looking okay. You know, once I tack it, I can build everything up like that, but that's no problem. Main thing is getting it tacked in the correct position. First things first, let's see what I got for the mounting system for the clutch master pedal. This right here is the clutch master cylinder from the Passat, also from Corrado's. What it is, we have that eyelet. That eyelet is plastic. What's the hole? The hole is a 10mm hole. Now you're probably saying, well, why don't you just use a bolt? You know, what you can do is you can weld onto the other side and just screw the bolt in. Well, you don't want that. Why is that? Because the bolt's threads, this is plastic, the bolt's threads are metal. Metal usually wins over plastic, as far as I'm concerned. So what do I need? Because I don't want the threads to go chomping into this eyelet. So I just found another pin. This came, I believe, off the clutch master cylinder from the Passat Corrado type. And all it does is a 10mm pin slides in there and it won't destroy the plastic eyelet. Now, I found this mount. This mount, I believe, was the split fold-down mount for either a Passat or an A4 or something like that. I don't really care. The big thing is, it's like 3/16 plate, you know, and it goes in there. They're 10mm. There's no play, so when you push the clutch, there's no play, and that's kind of what I want. And that way, I'll just clip it. I will cut this, you know, right down the center, bring them together, give me the correct width, and we're all set. So, and then we can figure out exactly where this is going to go on that plate, where these are going to actually go on the actual clutch pedal. So you basically have enough stiffness to when you push the clutch in, it's going to be good. And then we will cut the holes, put this in, bolt it in, do that. See, easy. Right there is right there. The base. What I'm going to have to do is I'm going to have to cut this off, but I'm going to have to tack this plate to it because I just can't keep it steady and exactly where I want it. But I'm going to have to use a lot less of this for this, which really makes me happy. Other than that, let's first. Let me clean this up. I got to bring it over to the bench and TIG weld it, and then we'll get on with building the entire assembly. Well, that's how it's going to look. I think it looks okay. I just did tacks over here, tacks on the bottom. I don't want to put too much heat in it until I pull all the master cylinders off, because I don't want to destroy the seals in the master cylinders, pretty much. Next thing is we have to do the clutch cylinder, the actuating rod. I'll pull it over here, give you a better look at it. Here it is. Here's the rod, and this is where it's going to have to be. This is at rest right there. Now, we have the mounts that we're going to use. Pretty much I'm just going to clean them up. Here's the pin. Put the pin through it. Put the pin through this. Lock this up. And this is exactly where it's going to go. Just give it a couple tacks and we'll be all set. Now, you're probably saying, well, why didn't he put it down on the other side like, you know, like this? Well, we're going to have to move the pedals over to the right because remember, the Coupe GT 4000 two-wheel drives are offset more to the right side than, you know, looking at it to the right side than the 4000. So we just have to move these. Plus, we have to change the pedals anyway. I mean, the pedal pads anyway, just to make it kind of look like the original. But first things first, let me go get my stuff back on. We'll clean this up, give it a couple of tacks. When it's in position, I think we're going to be all set. No, this is the pedal box right here. I mean, I have to trim up this base right here and bring it back into the pedal, which makes it triangular shape, so it'll be really, really stiff. I have to make small little things for this, but I have to pull all the bushings, all the Teflon bushings I have to pull out, or nylon bushings, whatever they use, whatever the material is. I got to pull them all out and then brace everything and weld it all up. As you notice, I didn't do anything on past here. On both sides, because when I have to shift the pedals over because it's a Quattro, it gives me plenty of room to do it with, no problem. So what I have to do now is I'm going to pull off everything and bring the aluminum over to the bench to weld that, and then I will weld up all of this. Yeah, I mean, actually it looks pretty cool, you know, and then I got to make a template and we're going to put everything together and stick it in the firewall. Take a look at this. This right here, I was trying to pull the last bushing out and I kind of chowdered it up right here. I took a little bit of a chunk off. I mean, it's not bad, but if you take a look, it's a bushing that's pressed into the pedal. Also, on this bushing, they did not make a concentric bushing where they had to align it correctly and put it in. So this is basically collapsed to here. This is expanded. What happens from it being pushed in, pushed in, pushed in forever, this is what happened. You know, this is my assumption. What am I going to do? I'm going to weld the pedal anyway. If this deteriorates out, you know what? I'm just going to drill it out and I'm going to either have do some bronze bushings to put in there, or I'm going to get some Teflon. I'll turn it down the lathe and I'll put it in. That's what it is. Because I'm going to weld this mount onto this bushing. So that's, you know, for stiffness. And this is going to go to here, right here. You know, there's going to be a plate right there. I'm going to probably cut this off and run it straight down. But I want it as strong as possible. I don't want any failures in this. And then after we get it installed, everything's all set. If this is not needed, I'm going to cut this off and use this hole right here, which I think I'm going to use for the return spring. So, all right, let me get my stuff back on and get the welding all, you know, get this all ground up and start welding up and cut this pedal and trim this all up and weld this. This is going to go here. It's going to go straight down to here, because I don't want to mess with this, because this is probably going to have to be cut on this side, brought over and brought down just to give me more clearance for the footwell in the because of the transmission tunnel. So, all right, let me get my stuff on, and we will get this thing all squared away and make it look nice.